All right. Hi, everyone. This will be the only time I will speak Spanish, and then I'm going to switch to English. This will be highly interactive. I hope you guys have fun. We're all going to make a qBraid account and get started. So please let me know if you run into any issues during the time. It shouldn't take too long. We're going to get you coding in less than 10 clicks. So first off, I'm going to practice this. It's straight from Google Translate. Hola a todos, bienvenidos al tutorial de qBraid. Le mostraré cómo usar qBraid para codificar cualquier lenguaje de computación cuántica. Okay, I tried my best. Anyways, I will show you how to use qBraid for coding in any quantum computing language. So first and foremost, I'd like everyone to go to account.qbraid.com. If you have not made an account, I highly recommend it. If you're doing a hackathon at Qiskit Fall Fest, or if you're doing a hackathon with us, for example, it's one of the easiest ways to get started coding without any pip install or any of these dependency issues that you might run into. But first off, I want everyone to make an account, and then once you are done, just send a smiley face in the chat, and then we'll go on. I recommend making a Google account because you don't have to click on so many of the, but you don't have to confirm your email and stuff. Yes, and I will share my screen. That is probably a good idea. And please, do not mind the Google Translate in the upper right corner. All right, once you have presented it, once you're there, yes, please log in. Please log in. I'm going to show you guys how to use qBraid for any of your quantum computing stuff. And as long as you research, I'm going to give you guys also some special access as well. I think I actually have a code just for this hackathon. Let me double check as you guys are getting ready. And just to talk about myself, Alberto has been a good friend since he was my mentor for the Qiskit or QSF mentorship program. And he's been very, very nice to me. And I've had the privilege to work with him. I graduated from Stanford with a physics degree, but most of the time I just code a lot of JavaScript at the moment. But hopefully I'll be going back to quantum stuff once our platform is in great shape. So you guys will be the ones that'll be testing and making sure that when I say it's in good shape, you guys can also agree that this is a great product that you guys might want to use. You can actually code in Qiskit. That's a great question, Miguel. But what's great about qBraid is that you're not tied to a certain provider. You're actually allowed to use any language that you find most comfortable. And then I'll show you the SDK, which allows you to then transpile from like a Qiskit to a Broadcat language as well. So let me make sure that I have the code correct. Okay. All right, so I think everyone's logged in at this point. I'm going to click on the top right here, and you should see profile, and click on account details, and you should type in Qiskit Fall 22. So I'm going to also drop this in chat. You can copy and paste it. And then you should submit it, and you should get your credits for this code as well. So once you've gotten your credits, we've given you permission to use our special SDK as well as our lab environment manager. For how many of you guys is this like a completely new experience to like do quantum computing, or how many of you guys are like experts? Like, type in the chat once you've finished adding your code, 5 being expert and then 1 being beginner, where you are in your quantum journey. I think it's great because quantum is just so open, and then like everyone is like on different parts of the path, but we're all trying to make quantum big. So awesome, 3, it's great. I put myself around there as well. I'm still learning a lot. Nice, cool. -5. Alberto, you're so funny. All right. looks like everyone has kind of entered the code. Make sure you get a green mark. If you haven't gotten the green mark, just let me know. Then what we want to do is we want to launch our lab. So click here and click Launch Lab. One moment, please, as I'm going to. All right, so while your lab is launching, it might take a little bit because it's your first time logging in. Take your time. While I see a lot of 3s, 2s, and 1s, what I have learned and what has helped me learn is actually, while your lab is loading, I'm going to show off one of our courses here. And in this course, you're actually able to learn about quantum computing in a super interactive way. Yes, someone mentioned you can forget about Qiskit. We've written all of this in Qiskit, so welcome, Falll Fast Mexico. You can actually run your circuit here and also, and also draw an output for your Qiskit circuit as well. And we also have interactive widgets for you to understand from a mathematical, computational, and a quantum physics background. Yes, I do this link. So we're going to make this site a little bit better. It's a little bit old right now, but this is one of our courses. It's endorsed by the White House Q12 initiative, and you can learn about basically up until Deutsch-Joseph's algorithm. So if you kind of know what's going on there, this might be a little more beginner, but it will kind of tell you about how to use bits. There's videos, there's questions and stuff. I think it's a great tutorial. We've used it at undergraduate and high school courses as well. And as well as like executive programs for companies. All right. Once you guys are there, let's double check and see that lab is loaded. For me, it's probably going to load very soon. But for anybody else, we're going to hold on tight. Once you have loaded your qBraid, just send me a message in the chat called qBraid. Not Q. I know some people will type in like qBraid. And people sometimes spell our company's name wrong. So don't be one of those people. Right. Making sure. Nice. As everyone is getting on. How did I get to this section? Oh, good point. So if you are a little lost because I've been jumping around, on your account page, on almost every tab, there's Launch Lab section. So all you have to do is just click Launch Lab, and it'll take you to that page that I just showed you. It does take a little bit because we're actually providing you computational access, so CPU, RAM, and there's a lot of like resources that we're going to like supply for you and set up. So it does take a little while. And this is actually lab.qbraid.com. So I can also drop that link. And if you have logged in, it should just automatically log you in. All right. Once again, once you guys are here and you see something similar to mine, maybe not that much files and folders and stuff going on, just type in qBraid and we'll be good to go again. Nice, nice, nice. It might take a little bit. I kind of forgot to make sure that we have large amounts of people coming on site, so I didn't set up for that. But next time we will. Lesson learned, so please be patient. Oh yes, dark mode. We're actually updating our themes and stuff, but if you want, this is just a standard Jupyter dark and light mode. And you can actually just click here and change it. Alberto, the challenge isn't out yet, right?
Yeah, not yet for the host. tomorrow we can share more about
Okay,
that.
sounds good. Let me pull up something for you guys, which Alberto and I worked on very recently. Alberto actually just merged my pull request because he owns this repository basically. So I'll show you guys a quick demo with this monthly challenge once we are do another demo here. So once you guys are done and you guys are here, I want you guys to first go to this thing called qBraid tutorial. Should be in your file system, and then you go to Amazon Broadcat examples and click getting started. And then you should open the notebook called running quantum circuits. Yes, this is not necessary. Right. Is everyone not getting lost so far? Just want to make sure. Okay, I'm going to assume silence is a good thing. So once you have gotten to this file, you can click add. And what you should see here is this Amazon Broadcat environment. I'm going to actually delete it right now. So this actually has all the quantum computing packages you'd need to access quantum computers from Amazon Broadcat. So all you have to do is just install, and then just wait for it to install. You can refresh and make sure that you know that it's installing. It will take a few more minutes, but after that, you're ready to start coding in Amazon Broadcat. I will run this command, and you will be able to access quantum computers using credits that you just applied through the code that I gave you guys, which was the Qiskit Falll 22 code. Oh, actually, you know what? I'm actually going to show you guys something. qBraid lab demo. Lab demo. Right. Oh, it's empty. Interesting. It might need some time to fill up. If it's empty, just refresh your page and it should fill up. If not, just let me know. All right. Oh, I also think there might be a glitch in your file system. If that case, I apologize. You might just need to watch, and I'll fix it in a bit. So, sorry about that, Fernando. Nice. All right, once it's installed, I want to get the message Amazon Broadcat in the chat. Oh, then I'll know you guys are ready to go. Or actually, oh, nice. Yes, Amazon Broadcat or your favorite quantum. Maybe let's do quantum gate. So like Hadamard or something. I don't know. Holy. So just let me know when you guys are there. If you guys are completely lost, you can also just message me in the chat. That is my job. I'm here to help you guys. I'm checking. If your account's not working, just let me know as well. It looks like Hugo. Maybe it looks like your account might be kind of struggling a bit. Just let me know. Okay, cool. Oh, mine has been installed. So that's great. I'm going to click activate once it's been installed. I'm going to close this so it's a little bigger. Make sure it's a little easier for everyone to see. Okay. So this is kind of the annoying part that we're going to fix soon, but you have to make sure you've activated the kernel as well. So now you've activated the Amazon broadcast kernel. Okay. All right, Alberto. Sorry about that. Once you have done so, you should see a line that says qBraid jobs enable Amazon broadcast or -N. If -N, just remove it and make sure there's only one space here. Then press Shift Enter, or you can press the plus button here and enable quantum jobs for Amazon broadcast. And I just want you guys to start just installing things and just running these cells up until you actually get all the gates for Amazon broadcast devices, which include Rigetti, IonQ, and OQC. We'll keep going and just set up a Falll circuit with a local simulator as well. Don't know if Rigetti is available at night, so we'll access IonQ with 10 shots. And there you have it. You've just ran your first Falll circuit on quantum computer. Is it possible to use Jupyter Notebook local and import all library? We actually, it's a good question. So qBraid read the docs actually has like a way to shim or access things from Jupyter VS Code. So that should be in here somewhere. You should be able to access the qBraid kernels through the VS Code from VS Code as well. We do have a VS Code local installation process where then you can submit jobs through our API locally. So just follow these instructions. I am going to show off our qBraid SDK, and I think that might kind of entice you to use our platform, though. Our SDK is not currently available as an open source. So the Hugo, sorry about that. Yeah, you're just keep trying. It does take a little while because I didn't prepare everyone to be running at the moment, but I think almost everyone should be online or have been kicked off. So, okay. All right. Boom, boom. Oh, look. And now my qBraid task for IonQ has been queued up. If you want to know what happened to your quantum jobs, you can actually just check here. And I think I should have one that's pending and see. I can just check that I have a quantum job that's pending from IonQ. And there you have it. You've just ran your quantum job, and you can then retrieve your job later on by just copying the job ID. And I don't remember the specific command, but I think you can just get the task ID and load it up. There you go. So you just have to copy it in here. And just run it. And it should show that it's still queued. All right. Hugo, I'm sorry, maybe if you just refresh your page if it's not working. But for everybody else, I hope I didn't jump around too much. But you should have, at this point, ran a circuit on IonQ, the Bell circuit, then be able to retrieve your job from IonQ, all in your all in basically this notebook here. So I'm just going to keep waiting to see if it's loaded. But it hasn't yet. So it might take a while. Toledo, did you make sure to run this line here where it says qBraid jobs enable Amazon broadcast with no -N? Oh, yay. There we go, Hugo. So essentially, run this section, run the imports, and again, what's great is you never have to pip install anything. You can check the gate sets that are available on all of these quantum computers and simulators. Then run your bell circuit, run it on a local simulator, get your results. You get the 50-50-ish. And then I'm asking you to run it on IonQ device. Mine is queued already. And then scroll all the way down to just load your quantum task and then check if it's running. If you're ever unsure where your quantum tasks are, they're all here in your quantum job info area. So you can actually check where your quantum jobs are and stuff. So once you've gotten to here, type in IonQ. And I will also note that you do have to skip a few cells. So skip the cell that talks about Rigetti because Rigetti is not available. So once you've run it on a local simulator, skip the part that says Rigetti and then just move down to the IonQ one. The quantum computers we have available are Amazon Braket simulators, including DM1, SV1, TN1, Rigetti, Xanadu, D-Waves, quantum annealers, IonQ, OQC, and we will have IBM's 27-qubit quantum computer available very soon as well in a pay-as-you-go format. Yes, great. Hugo, you are catching up real quick. So in your tutorials, let's say tutorials, and then you should see Amazon Braket examples, then getting started, then you should see the two here. In cell 4. Get device operation. Security token. Did you make sure to run the qBraid jobs enable Amazon Braket, Felipe?
Can you repeat the question, please?
Did you make sure to run qBraid jobs enable Amazon Braket without the -n?
Yes,
Make sure
yes.
that it just says this Amazon Braket.
Said that.
And okay, and did you make sure your kernel says Braket?
Okay.
So make sure that your kernel up here says Braket, or down here it should say Braket and idle. Nice, Felipe. Yeah, this is the tricky part. I think a lot of users get confused here, and we will try and make this better, but you want to make sure that you have like the Braket environment enabled. Yeah, so Hugo, you want to make sure that it's, after you've installed Braket, you want to make sure that the kernel is Python 3 Braket. Nice. There we go, Miguel. There we go. Yes. Right, once you guys have ran all of this and you have ran your first job on IonQ, I just want to show you guys a quick, cool feature of qBraid, our qBraid SDK. So if you guys have loved working on Qiskit, for example, we allow you to transpile. So you can change your circuit from SDK, from one SDK to another, and we can run it on various devices, as seen here. And with this, for example, we have the IBM Chasm simulator, the local one. We have a circuit here And what's happening here is that you can run the circuit on an IBM device. You can then run it on a Google device, an AWS device. And then you can actually get all of your jobs through our qBraid SDK, compare the results, and also transpile the circuit as well from between PyQuil, Circ, Qiskit, and Brocket. Yes. If you're interested in this, this does work in your notebook. You do have to install the qBraid SDK environment, but I highly recommend just trying it out. And so what you have here is a circuit wrapper, and then you can wrap your circuit. So you have a Qiskit circuit here, and then you can actually change it into a Brocket circuit, a Circ circuit, and then you can change it into a randomized circuit, change it from Brocket, PyQuil, Qiskit, Pennyway circuit, and it's always going to be the same, and the test will pass. Yes, I can show you how to install AWS packages. Go to Environments, plus Add, and then you should see the AWS Brocket environment. Just click Install, and it'll take a few minutes. If you are interested in the qBraid lab demo, here you go. It's right here. And then you just have to click Launch on qBraid, and we'll clone the repository into your account. So there you go. You have the qBraid lab demo. You will need to activate the qBraid SDK in the same way that you activate the Brocket. Anyone have any questions? And there you go. See, now I have the qBraid SDK lab demo in here. And I can actually also use the Git functionality here as well. Okay. So Alberto, did I have 30 minutes or an hour?
1 hour. You
Okay,
had more.
great.
50 minutes
Perfect.
more.
All right. Once everyone's like kind of getting the hang of the Brocket part, then I will ask everyone to then move on to install the qBraid SDK. So I want everyone to make sure that they can install the qBraid SDK. Because this package is like huge, it does take, I think, 3 to 4 minutes for it to install. So I'll wait with you guys. Make sure you install it. Then once you have ran your first quantum job on IonQ, go to the qBraid lab demo and click on Launch on qBraid and launch it and clone it into your qBraid account right here. So make sure you do this and clone it. I'm actually going to show off our CLI and rimwrap the qBraid lab demo from my own repository, so then I can do a fresh start with you guys. So I'm going to rimwrap qBraid lab demo. And if you're familiar with CLIs, this gives you sudo access. This is basically like your own Docker, and you can actually run anything in here. There you go. So while the SDK is loading, I'm going to double check here. I'm going to refresh. Looks like the SDK is still installing. While that's installing, if anyone has any questions, just let me know. All right. Wonder if my job is still initializing. Yeah, it might not be available right now. Oh no, it is. It's initializing. Great. So it's actually going to run soon. Great. Well then, I might as well go back here. and load the quantum task. Yep. Thank you, Miguel. Once you've gotten your the Amazon Brocket tutorial part done, just type in Qiskit. Well, that's Hugo, did you add the code in? Oh, okay. Miguel and Hugo, make sure to add in enough credits for your code. So I will provide you guys another code here. Type in EHNU6626 here, and you should get more credits. So this is our welcome code. You should actually see it in the email that you received from us. Please add that one. And Miguel, if you are running into that cell issue, I recommend reducing your shots to 10 so then you don't overspend on a demo. So try that one first, actually. Try and reduce it from maybe 1,000 shots to 10 shots. If you are unsure about how to use Brocket, for example, we also provide documentation. If you just click on the launcher here, on the very bottom, you see Quantum Docs. We have docs for Google, Microsoft, Pascal, QTech, Unitary Funds, and Condela, and so many more. If you're unsure, you can always click on this, and it'll take you to the documentation. Yes, we got 2,000 credits. And if you want to actually buy credits, we do provide them on the billing page. Highly recommend buying them. It's very easy to use quantum computers through us. Actually, I think it's the easiest way to access quantum computers. And I'm not biased at all, like whatsoever. I don't work at qBraid or anything, so yeah. Great, so it seems like you guys needed some credits. Make sure you get to the end of this and get your status for your job and refresh and see what happens. Still initializing. How's everybody else? Is everything going all right? All right, perfect. Yay, great, great, great. Make sure everyone's getting their credits. Make sure everyone's running their quantum jobs. Fantastic. Actually, this is an interesting part. If you guys are doing Qiskit Falll hackathon, but maybe you want to use like a Rigetti device, or maybe you want to use it on like an Oxford quantum computing device, or you want to run it on a bunch of quantum computers, I think we actually provide a really nice service here because if your project is in a Jupyter notebook, in the next tutorial I'm going to show you guys, we're going to use a qBraid SDK. Oh, perfect. And in the SDK, what's going to happen is you can write your code in Qiskit and then change it to Penny Lane or change it to PyQuil or any of these other languages and then submit it on an AWS Brocket job. So it might be cool to just like benchmark your algorithm in a very hand-wavy format. So that might be cool. All right. Where's my qBraid lab demo? Oh, I deleted it. Okay. So once the qBraid SDK has been loaded in, just click Activate here, and then go to the GitHub page that I sent. Felipe, you are a fast guy. And then just click Launch on qBraid. And it'll do the same thing that I showed you guys before. and it will copy it in for you. Also, I had a quick question. Was the person with the tutorial that was empty, is it still empty, Fernando? I hope it's not. Well, anyways, we now are in the qBraid lab demo, and let's get started with the transpiler first. What's great is that this is a qBraid repository, so I think it should just automatically pick up the SDK. Boom. All right. All right, now I'm going to go through the SDK demo. And just press Shift Enter, and we will see what is available here and what runs and what works. Oh, it's still connecting on my end. If it's running into connecting issues, just refresh the kernel. All right. Type in lab demo if or whatever you prefer once you have cloned the lab into your qBraid account. Hello, I'm back. Sorry. Your mic is off due to the size of the call. Oh, never mind. Going to reshare. All right. Is everyone good now? Sorry, I just kind of like left on accident. Okay. Your qBraid SDK should connect soon. Kernel is still connecting. I don't know why it's taking so long. Maybe it doesn't take so long. Oh, okay. There we go. It is now idle. I'm just checking here at the very bottom. It says busy or idle. And then you're going to just check the qBraid version, run these cells, and I will go through it with you guys. If anyone is kind of stuck or falling behind, just let me know. I can help you guys. I wonder if my job is done. Oh, it's still initializing. All right. In the meantime, qBraid is also doing its own hackathon called Hacks. This will be after, I think, Qiskit Fall Fest with Alberto. I highly recommend joining us if you're interested. We're doing like a variational quantum classifier. We have a few teams. It starts this Friday. And you can also check your progress. This is the same quantum jobs interface. And we also have some amazing speakers from all over the world speaking. And in fact, you can also apply to a mentorship program. And also kind of what's really cool is one of our prizes is actually to attend the MIT ACWAC. depending on your location, it'll be in person or virtual. There is like a application-ish process through for MIT IQuac. So if you win, you get through that. And what's really cool is if you win at MIT IQuac, you get to go to Abu Dhabi and compete. So these are just regular applications, but you can almost compete in like the Grand Slam of quantum computing hackathons, and you can start it off with the qBraid hacks. So I recommend joining us as well. All you have to do is just click on the hacks tab and then just fill out the type form. All right. And the link for that is here. Is everyone here at the SDK demo? Did it work? Yes? Maybe? I have no idea. Yes. Okay, finally. Nice. All right. So once you have ran all the importing cells, where is it? Good question. What you want to do is go to github.com/qbraid/qbraid lab demo. And then just click on launch on lab, and it will actually just take you back to your lab and clone the entire repository for you. All right, I'm going to do the very cool demo. So what you're going to do is run a Bell circuit again, but we're going to show you that you can actually translate this from Brocket to Circ, all the way back to Brocket from Qiskit. Now we've wrapped it into a Qiskit circuit, and now it's a Circ circuit, and it still preserves a unitary, which is very important. Essentially, if you didn't preserve the unitary, you didn't actually transpile correctly. So while we're going to do a little bit of a hard example, we're actually going to do all of these gates imported from Qiskit. Now we're going to draw it out. This is a Qiskit circuit. And then we're going to translate it to Brocket, works perfectly. Translate to Circ, works perfectly. And once again, the unitary is close. The matrices are all close to each other, and so that's correct. And now we're actually going to do some randomly generated circuits. So we're going to use the Circ's testing random circuit function, where now we have a bunch of random circuits or random gates. Now we're going to transpile it into an Amazon Brocket circuit. It works fine. PyQuil circuit, a Qiskit circuit, and a penny lane circuit. And now we're going to take that penny lane circuit and then make it transpile it back to a Circ circuit. So what we did here is we took the Google Circ circuit, translated to Brocket, took the Brocket, translated into PyQuil, then to Qiskit, then to penny lane, and then back to Circ. And lo and behold, boom, the unitary is still the same, and we're going to test using the Circ testing function, and it works. So boom, all of it is, this is a wonderful tool that I'd love for you guys to use to not only change your circuits and transpile them, but maybe if you have a quantum machine learning portion of your code that's written in penny lane and the circuit, you want to translate it now to Amazon Brocket, qBraid SDK is perfect for it. Further, you can actually just run quantum jobs through qBraid as well. So once again, you check the qBraid CLI and make sure that the version is correct. Then you can all the devices that are available on qBraid SDK here. And this device, what do plus new event? Yes. Yeah, so what kind of circuits could have problems between the different transpilers? That's a good question, Miguel. So some of them could be where in Qiskit you can actually make custom gates, and I think in Circ as well. So some other open source versions of it don't do it as well, where sometimes your circuit is not transpiled correctly. And that could also even be for just like Chasm files as well, because I think Qiskit runs on Chasm 3.0 or the latest version with some of their own add-ons or ways of just like making custom functions and custom gates. whereas like other quantum computing frameworks are not supporting that. So that's actually where some of our magic comes in, where we actually kind of take care of a lot of these on the back end and make sure that your transpiled circuit is going to be always the same, regardless of the language. Hugo, just to make sure you want the qBraid SDK environment, you want to go through here and actually just add the qBraid SDK environment. All right. Now, what you can do is, if you've done some like NoSQL based database filtering and stuff, you can actually get similar to like MongoDB, you can actually like query for certain devices that you're looking for. So if you're looking for a state vector simulator from AWS and IBM, you can actually look for them here. All of them are available. And then you're looking for a QPU, then you can actually search for them as well. And you also want to check which packages are running. You can do a lot of querying from the qBraid SDK. What's even cool is that you can then run, and you do need to actually have a IBM account right now. We will set this up where for the the 27 qubit, you won't have to. But for now, you do need to do this just because IBM would prefer to have everyone use their own token. So I'm just going to kill that. Once again, we're going to make the same circuit and run it on Qiskit. Oh, whoops. Yes, we're not going to run it on IBM, sorry. The issue here is that, again, you'd have to add your own Qiskit credentials. So if you want for this hackathon, you just have to, I think, do IBM q.save and just save your credentials, and then you'll be able to run this. And for now, we're going to do the Google and AWS quantum computing density matrix simulators. And then you run the Qiskit circuit. Servers. Well, right here, I'm not sure if I'm answering your question correctly, but like in this line, we just ran it on. We ran one Qiskit circuit. Yeah, I'm not entirely sure if you want a Docker image, but let me just say that we had a Qiskit circuit here. You guys saw the transpiling. We do that for you, and then you're actually able to run it on Google and AWS. And then also just get your jobs again. It's the same thing as here. And you'll be able to retrieve your jobs. Then you can wait for the final state, get your results, and then compare them. I don't think we have IBM available, so you might want to. Right. So you're kind of asking like, why don't we have like the SDK installed in like the AWS Rocket environment so then you can use it like everywhere, right? Felipe, is that correct? Okay. Yes, that's correct. That's a great point. We will get to that. We have been kind of thinking about our strategy about like, oh, should we make it the SDK globally available, or should we make it like only available on certain environments? I personally am of the opinion that it should be available in your Amazon Braket environment or your Qiskit environment. So whenever you need it, you can use it. But right now, it's only available through the qBraid SDK environment. Please be patient with us. We are a small startup. It's just the three of us in terms of the coding team, and then 2 or 3 developers in India who do a lot of the UI UX stuff in the front end. So we'll get there. Just trust us. All right, finally, so I've shown you guys a learning platform. I've shown you guys the way to run quantum circuits in less than literally like 10 clicks. I've shown you our SDK, which allows you to translate between various quantum circuits. Now, what's really cool is once you guys are done with your quantum projects, for example, and you want to publish it, say it's like, oh, I worked on, I don't know what BNB is. I hope it's, oh, okay, yes. This might be a little better. So say you like learn a little bit about quantum computing and you like wrote your own notebook. You can then publish your notebook here, add an image, and then publish it onto qBraid. So then all these other people can learn from your media page. So we have some circuits here or some notebooks here available for you. And this one's actually written by a high schooler who took the qubit by qubit course. So you can actually run the code and then get random bits and then do the QKD demo as well. So I think you still need to install, but then you can do the QKD demo that she has written. And then if you really like her stuff, you can share it, or you can also launch it on your lab, I think, if this thing isn't broken. So I wonder why it's not working. I think this one should work. Okay, this launch on lab button might be broken. So I will fix that, but the point of the story is you can post your blogs and then you'll be able to share with other people as well, just like Medium, but you can run your code and it's about quantum, so it's way cooler. All right. Anyone have any questions? All right. Sweet. Let me know. I'll drop off my, I think Ryan dropped off his LinkedIn. I can drop my LinkedIn as well. So if you guys want to learn more about qBraid, maybe you're interested in working with us, maybe you want to buy some credits, which would be cool. Maybe you're interested in like subscriptions for your research group. Just message me on LinkedIn. And also sign up for Hacks. We've worked really hard on it, and we want people to learn more quantum. Once you've done your Qiskit Fall Fest, you still have time to do your qBraid hacks and show off all your cool work. So, yeah. Awesome.
What
Great.
hackathons in the superposition?
Yeah. Both hackathons are, I think there's like 3 hackathons, maybe even like 4 or 5 hackathons in superposition at the moment. So
That is a great moment to do a project for quantum computing.
yes.
And using qBraid.
Yes. Yes.
Okay. Let me stop the video.